Okay, so today we're on Unit 8B.5. And today we're just going to work on analyze statements about logs. Analyze statements about logs. Okay, so for example number 1, thank you. I would like you to write an equivalent statement to 27 to the 1/3 equals 3. Write an equivalent statement to 27 to the 1/3 equals 3. So that sounds really vague. Basically what we're going over today is a lot of the multiple choice questions on your test, which you're not taking a test for like 2 or 3 more weeks, okay, are going to look like this. And it's going to say, determine which is an equivalent statement. All that really means, that really just means to rewrite. It means you need to rewrite in log or exponent form. Rewrite in log or exponent form. So whatever form it's in, I want you to rewrite it in the other form and simplify if possible. Okay, so rewrite in either log or exponent form, whichever one it's not in. So rewrite it in the other form and then simplify if you can. So this is already written in exponent form. So we want you to write this in log form. Okay, so how would you write this in log form? Ben. Log base 27 of 3 equals 1/3. That's it. Okay, just rewriting things from log form to exponent form. And that's your answer. That is an equivalent statement. Yes, that's it. Okay, so it's basically just practicing going between the two forms. Okay, so hopefully this homework tonight should be like super easy. For number 2, same thing. Write an equivalent statement. Okay, write an equivalent statement to log D equals G. Log D equals G. Write an equivalent statement. So first off, what's missing here? The base 10. Okay, so first thing you have to do is put in the base 10. This is written in log form, so to write it in the other form, we need to write it in exponent form. How would you write this in exponential form? 10 to the G equals D. That's it. Okay, we're just switching forms today. That's it. Questions on how I did that? Not too bad, hopefully. Say it again. How do you... Good. Okay. For number 3. For this one, this is a little bit different. This is almost exactly like a test question. Okay, I'd like to know, when is the following statement true? Okay, and your choices are going to be for all values of x, for some values of x, for no values of x, and can't determine. So when is the following statement true? That 2 to the power of log base 2 of x equals x. When is that true? Is that always true, sometimes true, or never true, or you don't know? There's not enough information to figure it out. When is that true? Always, sometimes, or never, or you can't determine. What kind of simplifying can you do here? This is an upside down seagull problem, right? But is that always, sometimes, or never true? First off, you never pick can't determine. That's like never going to be the answer. So don't even entertain that thought. So it's basically always, sometimes, or never. When is this seagull problem true? What do you know about logs? Logs, I said, are allergic to what? Negatives. So how do you know if it's allergic to a negative? Where can the negative not be? The log can't be, or the negative can't be right next to the log or on the same level as the log. So would this have any issues? Yes. Can this equal, like for instance, would a log base 2 of -4, would that equal -4? No. You can't do that. Okay, logs are allergic to negatives. So this would not ever work if it was a negative, a 0, or a 1. Okay, so this one is only true for some values of x. Okay, this is only true for some values of x. The ones that are upside down like this, so log base 2 of 2 to the y, these ones are always true because no matter what, the negative couldn't be in the base and it couldn't be right next to it because there's numbers filled in there. So you can have a negative up in the top, okay, up in the exponent. This one is always true. This one is only sometimes true. Okay, so you just have to get those two straight. That is almost an exact test question. Okay, and for sure, that's going to be on your notes quiz. Okay, I think this exact problem is on your notes quiz. Okay, so it's just something you kind of have to memorize as a technicality. Okay, next one for number 4. I'd like to know, again, write an equivalent equation, or expression, excuse me. Write an equivalent statement. Write an equivalent statement to log base 2 of 32 to the x. Log base 2 of 32 to the x. Write an equivalent statement to that. So since this is in log form, how would you simplify this? Any ideas? How'd you do it? What are we always trying to turn these into? You remember? You want to turn this into the same base so we can make this a seagull problem. So could I rewrite this with a base of 2? Log base 2 of 2 to what power equals 32? 2 to the 5th raised to the x. Then what do I do with those exponents? Do I add them or multiply them? Do I add the 5 or multiply the 5 and the x? Multiply them. If I rewrote this, what would it be equal to when it's simplified? What would it be equal to when it's simplified? This is a seagull problem. This is equal to just 5x. So if I asked you to write an equivalent statement, the equivalent statement is 5x. That's it. Not 5 equals x, not x equals 5, just 5x. That's your answer. Okay, so this became a seagull problem. 5x is it. Okay, so you're just simplifying. And then the last one I want to do, number 5. Okay, same thing. I'd like you to write an equivalent statement. Write an equivalent statement to log of 100 to the x. Write an equivalent statement to log of 100 to the x power. So, Thomas, what's missing? No. Tanner, what's missing? The base 10. Okay, so if you rewrote this, this is log base 10 of 10 to the what power equals 100. 10 to the second times the x. Then what does this become? This is a Siegel problem. 2x is your answer. Okay, so an equivalent statement to this is just 2x. That's your answer. Okay, you guys have 11 of these problems tonight. Okay, you're doing worksheet 5. Please make sure that you actually write down the questions. Okay, so write down the equation and the answer. I don't just want ABCs. Okay, and